For the last decade or so, the story of the Middle East energy transition was all about one thing: scale. Just building bigger and bigger. But that's changing. A really big shift is happening right now, moving beyond just massive projects to something way more complex, and frankly, way more important: control.
Yeah, that whole era of just building for scale kind of hit a wall because, look, simply having a huge solar park doesn't do you much good if you can't guarantee power when a cloud rolls in. The old ambition was all about building the biggest and the best, but now the real strategic need is control. The new game is all about managing these incredibly complex, interconnected systems so they're reliable, affordable, and secure every single day.
And this isn't some forecast about the future, this is happening right now. The entire conversation at the recent World Future Energy Summit in Abu Dhabi made it totally clear. The days of just announcing massive goals are kind of over. We are now deep in the era of disciplined execution.
Okay, so how do you manage this explosion of complexity? The answer isn't more steel and glass. It's software. This is the new kind of infrastructure, right? It's that invisible layer that actually makes everything else work together. We're calling this the operating layer, and you can think of it as the brain of the energy system. It's the software and AI that deliver the control and precision you need to run a modern grid. It's what turns all those individual power plants and solar panels into one single intelligent system that you can actually rely on.
So, operating layer sounds a little abstract, I get it. What does it actually look like in the real world? Let's dive into 3 examples that are happening as we speak.
First up, we've got to talk about the biggest challenge for renewables: volatility. The sun doesn't always shine, the wind doesn't always blow. Figuring out how to manage that unpredictability is absolutely critical if you want a stable grid.
And get this, new digital forecasting tools are cutting the errors in predicting renewable output by up to 30%. Now that might sound technical, but that is a massive improvement. It has a direct impact on reliability and, of course, on cost.
So, how does it work? Well, these systems are just constantly crunching data. They're looking at weather patterns, the health of the equipment, historical output from years past. All of this gives grid operators the confidence they need to bring more renewables online, not just as a bonus source of power, but as a core, dependable part of the infrastructure.
Now, this intelligence isn't just for the power plants. It's also completely changing the electricity grid itself.
The old grid was basically a one-way street. Power flows from a big plant, down the wires, to your home. That's it. But software allows for active management, turning the grid into this dynamic two-way network where supply and demand are being balanced constantly in real time.
And in places like Dubai, you can see this in action. They're using predictive software, smart meters, automated systems, all to squeeze more value out of the infrastructure they already have instead of just building more and more power plants for those few peak hours. It's all about working smarter, not just bigger.
And for our third example, let's look beyond the electricity grid and into heavy industry. Some of the toughest sectors out there to decarbonize.
There's this incredible pilot project in Fujairah that's capturing CO2 from cement production and literally turning it into solid rock. It's a process called mineralization. Think about that. They're permanently locking away carbon. And software is what makes this whole thing possible at an industrial scale. It helps find the right places to do it, it models all the complex chemistry, and it speeds up development. It's the key to taking these amazing ideas from a lab and putting them into the real world.
But all of this intelligence, all of this computing power, it creates a really fascinating paradox.
Because we have to ask ourselves, right, what's the energy cost for all this digital infrastructure that's running in the background? This chart here shows the dilemma perfectly. As our efforts to decarbonize ramp up, so does the energy consumption of the data centers and AI systems making it all possible. We could end up in a situation where the efficiency gains in one area are just canceled out by rising demand in another.
The good news is the region is already getting way ahead of this. The strategy is pretty simple. Align the digital and the energy infrastructure. So you have projects like G42 Stargate Campus, which are designed from the ground up to be powered by clean energy. You're basically connecting the problem directly to its own solution. And this brings us to the final and maybe the most important takeaway from this entire shift. Technology by itself is never, ever the answer.
Just as the leaders at the summit kept saying, the best tools in the world are only as good as the strategy behind them. The actual outcomes depend completely on how these technologies are governed and folded into real policy.
So what does that governance actually look like? Well, it means having clear lines of accountability. It means using transparent metrics so you can actually measure if you're making progress.
And it means real coordination between all the different sectors. Because without that, the complexity is just going to grow way faster than our ability to control it.
So as the Middle East really digs into this new phase of its energy transition, the focus has fundamentally changed. It's not just about building capacity anymore. The future of energy security is going to be determined by control, by reliability, and by governance.
Which, leaves us with one final thought to chew on. The software, the AI, the hardware, all of the tools are here, and they're getting more powerful every single day. The real question is whether the human discipline to govern them effectively is keeping pace.